All right, part 2 of key features is when we're going to be graphing quadratic functions by hand instead of using the Desmos, which we'll get to in a minute. But you can do this, you need to do this or would do this when you want to find the axis of symmetry, and that is something that splits the graph in half, or a line of reflection, if you will. So you should know that the standard form of an equation is y equals ax squared plus bx plus c. If you do not know that, stop, write that down in your notes. You need to know the standard form. I'm going to refer to that. It's very important that you understand that. All right, so a, b, and c are what we call constants. In other words, there's some kind of number. It can be a fraction, can be a decimal, can be a negative, can be a positive. Whatever that is, it's not going to change. What changes is your variable's x. A is the leading coefficient. A, B, and C are also constant terms. X, the letters X and Y are variables. So those are the things you need to know there. That last one wasn't important. So when you're graphing a quadratic function, it is a parabola. The shape is a U, parabola. The parabola can either open up, so it opens up here, or open down like the green. If it opens up, you have a minimum. The vertex is very important there. The vertex, that's the vertex. So that's a relative minimum, if you will. If it opens downward, like the green graph, you are going to have a maximum. So what you need to understand is if the shape is like a valley, you're going to have a minimum. If it's like a mountain, you're going to have a maximum. And you didn't need the bottom part. We'll get to that in a minute. So standard form of a function, you have that. The parabola will open up if a is a positive value. So a, in your standard form, if that number is above 0, your graph is going to open up like it is in pink here. Open up, so you're going to have a minimum. If it opens down, it is a value of negative, anything less than 0, and you will have a maximum. And a cannot equal 0. All right, so parabolas are symmetric. If you drew a line right down the middle of this graph, that is the axis of symmetry. That's what is going to cut that graph in half. If you fold it over on the line, they would be identical. So it's line of reflection, axis of symmetry. Axis of symmetry is always your x value. So there's another visual for you. And it also passes through the vertex 100% of the time. So to find axis of symmetry, we write the equation x equals negative b over 2a. We get those numbers from the standard form of an equation. So for example, we are to find the axis of symmetry for this equation here. Your a is 3, your b is 18, and it coincides with your standard form of the equation. So there's your a and negative 18, put that up there. A negative 18 turns it positive. And then you have 2 times a, which is 3. And then you go ahead and reduce that, so your axis of symmetry is 3. So you're just plugging numbers in a formula. So AOS, axis of symmetry, x equals 3. Always be your x value. To find the vertex from this, you're going to use your x coordinate that you just found, and you're going to plug it into the equation. So let's do another example to find this. We are to find the axis of symmetry first. So b is 8, a is negative 2, so let's plug it in the equation x equals negative b over 2a. So in doing so and reducing, you see that the vertex, or the x value, is 2. That is your axis of symmetry. To find the other part, the y value, you take that 2 and you plug it in for all the x values in your original equation. So here I rewrote the equation without the x, and I'm going to plug in my value of 2 and simplify, and you can see that it's 5. So the vertex is your x value, axis of symmetry, and after plugging it in, you'll see that it's a 5. So 2, 5 is your vertex. Now, what I want you to do is, because the tool's available, is to use Desmos. Plug this into Desmos, and you can find where the vertex is, and you will see that it is 2, 5. So I'm not going to go into graphing it on a actual graph, because I'm just going to go through and let you see, because you are able to put it in Desmos. You're allowed to use the tools. I'm a big advocate for using the tools you have. So you do not need to go any further, so we're going to stop the lesson here.